Welcome to the first video for the Black Belt Coder YouTube channel. In this video, we'll kick off our C# Basics series and discuss C# data types. These data types define the different ways your C# code can store data. In order to store data, you will need to create an instance of one of these data types. Probably the most common data type is the int, which is short for integer. In order to create an instance of an integer variable, which you can store data in, you would declare it like this. This declares an integer with the name I. An instance of an int data type can store any non-fractional number within the range of about -2 billion to +2 billion. And we can use an integer like this, something like, set it to 1,000. We could create another one, j equals 1,000, and we could define an integer called k, and it equals I plus j. And we can write the results. And so the window doesn't close immediately and waits for us to press a key. We'll do a read line. And I can run this. And it prints 2,000, which is the sum of 1,000 and 1,000. An int data type uses 4 bytes of memory. Now, if you know your code won't need a number anywhere near 2 billion, you can use a smaller data type that uses less memory. In fact, the byte data type only uses 1 byte of memory. And we can declare that. Something like that. In practice, saving a few bytes of memory on a modern Windows computer is hardly worth the effort. However, when you're saving a lot of data to a file or over a network connection, you may decide to use smaller data types to minimize the space required to hold your data. If you need to store fractional numbers, you can use a data type that supports this. As with integer data types, there are different floating point data types, some that support a larger range of values at the cost of using more memory. And for example, we can use a double. And set that to a fractional value. And if you need to store text, you could use the string data type. Finally, you can create your own data types by defining a class and then declaring an instance of your class. So let's create a simple class here. Call it a point class with a simple x and y. And I can declare an instance of that just by going point and then giving it a name. I will discuss classes more in future videos. For now, I just want to establish that classes are themselves data types. To determine the size of a data type, that is, how many bytes of memory it occupies, you can use the size of operator. And that would look something like this. And I'll run this, and I don't know if you can see it. It says 4, and indeed an int takes 4 bytes of memory. In addition, the types themselves have methods that you can use. These methods include the read-only min value and max value properties. And that would look something like this. Declare an integer called, or an int called min, and set it to int dot min value, and create a int called max and set it to int dot max value, and we can display those. And run that. And this shows us the minimum value and the maximum value that can possibly be stored in an int variable. Here's some code I've already typed in. It shows the size and the minimum value and maximum values of a number of data types. And let me run this. And it shows all these data types, the number of bytes in memory that the type occupies, and the minimum and maximum values that the types can hold. So using the size of operator and the properties on the type names themselves, you can obtain this additional information about these types. Data types can be categorized into two broad categories. That's value data types and reference types. Examples of value types are int, byte, and double. Instances of these data types use a small number of bytes to hold your data. Examples of reference types are string and all class types. Instances of these data types use a small number of bytes to hold the address of your data. That address will be the memory location where additional data is stored, which may be much larger. For example, consider a string variable. When you assign a large string to it, it must allocate more memory to hold a larger amount of data. However, the variable itself doesn't change size. It holds the address to the memory that must grow larger. In some cases, the memory must be moved to another address in order to be made larger, but the memory of the string variable doesn't move. That description might be a little confusing. If it is, just remember that value types hold the data you assign to them, while reference types hold a reference to another block of memory, and the other block of memory is where your data is actually stored. One characteristic of reference types is that their value will initially be null, which means they don't reference any data. Calling a method or property of a reference data type that is set to null will result in a null reference exception. In this case, an instant of the type has been created, but it does not yet hold a valid reference to the memory that holds the data. Normally, value types cannot be null. However, new versions of .NET have introduced nullable types. This syntax can be used to make a nullable int, for example, which can hold the value of null. And I'll show that. And the syntax for doing a nullable type is just to follow it with a question mark. So I can create I, and I can set it to null. This is useful for things such as holding an int value from a database, which in some cases can be null. .NET provides some other cool features with simple data types. For example, going back to our int example, although I is not an object, it can in fact have methods and properties. We can use the toString method. Even though an int is just 4 bytes to hold your data, you can use this syntax to convert the int to a string. .NET allows you to use this syntax to treat the int as though it were a class with methods and properties. This is called boxing. This can be handy, but you should note that there is some overhead to make this happen, and code that does this a lot might not run as fast. Finally, I should point out that you may see other data type names associated with .NET, and you can use these directly from C#. One of them is system.int32. It's important to understand that under the hood this is exactly the same as the int we used before. System.int32 is the name of a data type in the Common Language Runtime. However, when you use int in C#, it gets mapped to system.int32. And so this code is exactly the same as if you declared it using an int. In fact, if we use an int and we then print the type, we can do that using i.getType and run that. It actually says system.int32. So even though we use the int to declare the data type, in .NET it gets mapped to the system.int32. Now, when you're programming in C Sharp, the preferred syntax is to use the C Sharp name, int in this case. So in this video, we gave an introduction to C Sharp data types. We learned that there are a number of different data types that can be used for storing different types of data. We talked about how all .NET data types can be categorized into either value types or reference types. We talked a little bit about boxing, and we learned that C Sharp types get mapped to Common Language Runtime data types. So that's it. Thanks for watching.